This is a tutorial for question 10 on Unit 3 practice exam. If we were to run this on the Data Studio Lab, it would give you a graph that looks a lot like this. It's not exactly to scale, but it's pretty good. It would give you a graph that looks a lot like this, and we would just add the numbers in there, match them up, and see if we get the right values. If we're going to answer this question, a lot of times what we do is we would think about question 5 first. So I'm going to work toward question 5, and I'm going to kind of go back and answer questions 1, 2, 3, and 4 using that question 5. I'm going to kind of backwards engineer the answers to the other ones. So first of all, let's look at the overall question. I'm going to look at this part, and then I'm going to go skip down to question 5. So it says a 2 kilogram object moves to the right at 2 meters per second. So what I have there is a 2 kilogram object moving to the right at 2 meters per second. So that's my object right here, 2 kilogram object moving to the right at 2 meters per second. Then it says it collides with a 4 kilogram block moving to the left at 1 meter per second. So that is the it collides with the object moving to the left, which is -1. So then I have 4 times a -1. Okay, then I ask some questions about the individual aspects of what's going on here. I'll go back to that in a second. I'm going to go down to question number 5. It says after the collision. So after the collision, that's where you have your big equal sign. Before and after, the net momentum before is equal to the net momentum after. So after the collision, the 2 kilogram object, which in this case is our blue, moves to the left at 2 meters per second. So now it's bounced off and is going the opposite direction. So this is a bounce, and they haven't crossed paths. They've just changed direction. So this is a velocity graph. Remember, it's not a distance graph. So it was going 1 meter per second to the right. Now it is going 2 meters per second to the left. So now that same object that was going 1 is now going -2. Now remember, these have to be equal. So whatever we have on this side is going to be equal to whatever we have on this side, which gives us our final relationship, which says what is the velocity of the 4 kilogram object after the collision. So that's actually our question. This is the V, which is our question right there. What is that velocity? So we have plus 4V. So we're trying to figure out what that is in question number 5. So we could go ahead and answer this stuff right now if we wanted to. We would say 2 times 1 is 2, plus 4 times a -1 is a -4, equals, and then I have 2 times a -2 is a -4, and then here I have plus 4V. Okay, I'm going to go ahead and continue this. Maybe I'll use a different color just because it's going to be too hard to keep the colors coordinated. So I have, I have a typo here, or a right-o. This is supposed to be 4 times 2, isn't it? So I have to go back and say that this is a 2 kilogram object, moves to the right at 2 meters per second. And so this is 2 kilogram object, moves to the right at 2 meters per second. So this is a 4. So 4 plus a -4 is 0. And 0 is equal to -4 plus 4V. And so I have 4 equals 4V. And so I have V equals 1 meter per second. So if I put these in back into the original equation, I have this is 0. And on the right, I would have -4 plus 4 times 1. So -4 plus 4 is also 0. So plugging that back into the original equation, that tells us that our left side and our right side are equal. So looking over here, this is actually the answer to question number 1. This is the answer to question number 2. This is the answer to question number 3. And of course, this is the answer to question number 4. They're equal. And we already solved question number 5 right there.